We need to find a better way. So looking into biology as an answer for that. My early inspiration was the marine environment, looking at all aspects of shells, the biomineralization, our bones, our teeth, and studying what are these different processes and what's causing that reaction to happen.
Hey, Karl.
Hey, Erum. How's it going?
It's going. We have to get right to it, right? We have a great episode in line.
We do. This is going to be our live recording that we did on July 31st in New York City at IndieBio with Ginger Dozier of Biomason.
Yeah, so let's get right to it. Let us take it away.
About the event today, Grow Everything, a podcast focused on most innovative topics in synthetic biology. And they're bringing today an amazing speaker, Ginger Dozier. Now I would like to please invite them to the stage, and they will now spark an exciting conversation about this.
Just want to say thank you to everyone for being here and for joining us on our first ever live podcast. This was a completely sold out event. Even though you can see there are some spaces in here, we had 200 people sign up. There was a waiting list. So congratulations for making it.
Yeah. Nice.
Just by way of background, I'm Karl Schmieder. I run a consulting firm called Messaging Lab. We help build biotech businesses. I've actually been on this stage before with my partner, Erum. We've taught a class here to biotech businesses, which is something we do. And we also run the Grow Everything podcast. We started the Grow Everything podcast about 2 years ago. We're about 90 episodes in. And the reason we were motivated to start it was two reasons. One, we kept hearing about all this fantastic innovation happening in the biotech space, crazy stuff like growing bricks, which we'll get into, and then all the things that are happening on the biomedical side of the world. But the other reason we were motivated to start the podcast is because all the other biotech podcasts are talking to people in the biotech industry. So they're insider podcasts. And we really make an effort to make the podcast very accessible to the public. We're not Joe Rogan. We're not Chelsea Handler yet. We're not Call Me Daddy, but we're working towards it. We joke around that we're the fastest growing biotech podcast. We've had incredible growth. We're nearing 30,000 plays after 90 episodes. I want to say thank you to our friends at Biotech XYZ for hosting us today. We've been to their events. We support them. And with that, let me hand it off to my partner, Erum.
Karl, thank you. And I really want to take a moment to thank you for being an incredible business partner and co-host of the Grow Everything podcast. I pinch myself every day for the opportunity to work with you. So thank you so much. And I also want to take the time to thank today's event sponsors. So we have Millipore Sigma, Biolabs, and IndieBio, as we mentioned. Millipore Sigma, I've known for a very long time as a young scientist when I was working in the laboratories of GlaxoSmithKline and then J&J. So Millipore Sigma is clearly a leader in providing services and products for research organizations all the way from the lab to commercialization. And they do everything from reagents to labware, supply chain solutions, packaging capabilities, technical support, e-commerce solutions, and more. So clearly, they provide everything you need to optimize your chemical and biological workflows. Two other organizations I want to mention that are, again, near and dear to our hearts, Biolabs at NYU Langone, and they are a collaborative biotech co-working space in Manhattan. They have created a vibrant community where they develop groundbreaking research and provide access to shared resources, networking opportunities, and mentorship from industry experts. We at Messaging Lab had a great opportunity to work with them on a strategic communications workshop, and I want to give a special shout out to Glynis and Clive for holding it down at Biolabs. IndieBio. IndieBio is a program of the #1 early stage deep tech fund, SOSV. They do have some of the brightest and most passionate people that I ever met, not only in their portfolio, but also among their team. And I do want to give a special shout out to our dear friend Sabria Stukes, who is Chief Science Officer at IndieBio and partner at SOSV. So I wanted to give her a special shout out because we love her. Finally, we want to thank you, our audience, both live and on the podcast, for being super curious about scientific advancement and the bioeconomy. So I'm going to hand it back over to Karl.
All right. So also I want to say thanks to Bethany and to Stephen Chambers, who are also at IndieBio. So thanks you guys for having us here. We really appreciate it. One thing you should know about the podcast, or the way a podcast is recorded, is there is a lot of back and forth. And a lot of the things that we do is like, I'll interrupt Erum, she'll interrupt me. These are the things that never get seen or heard by the audience because they get edited out in post-production. We do a lot of post-production. So you might hear a little bit of that today. Like I sometimes will mansplain things. I get interrupted for doing that because it is a wrong thing to do. Sometimes I'm the one who gets woman-splained and I have to interrupt
sorry about that. Yeah.
But we do a lot of post-production. And one of the things that we try to do is keep things very accessible, because what we're trying to do is grow this community much bigger than the normal academic entrepreneur investors. So with that, I'd like to introduce Ginger Dozier. I actually met Ginger back in 2014, about 20 blocks from here at the first Biofabricate conference. And Biofabricate is a conference that brings together the people using biology as a technology to innovate the material world. It turns out that the fashion and construction industries are two of the most polluting industries on the planet. So it makes sense that people are using biological solutions to green or make those industries more sustainable. And when I met Ginger, she was on stage describing Biomason, which is a company that was growing bricks. To me, that was mind-blowing. I felt like it was in the right place at the right time, because I had always imagined that biotech wouldn't just be for healthcare, but it would be applied to everything we do every day and everything we use. And so I incorporated Biomason's story into my ability to tell stories about biotech to people who really don't know anything about biotech. So we'll be talking about that with Ginger. And I reconnected with Ginger last year. In the 9 subsequent years that we hadn't seen each other, she had grown Biomason, had taken it through some very serious fundings. And then we ended up meeting each other in Washington, D.C., in Congress at an event that was showcasing biotech products or bioeconomy products to members of Congress. We reconnected and we decided we would have you on the podcast. So Ginger has been on the podcast before, and we've had a lot of conversations since then. So I'm excited to have this conversation for us to interview you again, Ginger. And just by way of background, Ginger will get into this. She's trained as an architect. She went to the Cranbrook Academy, and she was also a professor at a university in the United Arab Emirates. And then she started Biomason in her bedroom and subsequently grew that company. And now she's going to tell us about a new project called the Biome Consortia. So with that, let's start the interview.
Yes. Awesome. I get the privilege of asking the hardest question and really get us all on the same page. And the question is, what is synthetic biology? And what is it in comparison to natural biology? Is it bioengineering, genetic engineering? Can you simplify that for us?
Yes. Thank you so much for the question. I'm glad that we get to start with definitions, because it's about time,
Yes.
to talk about the definitions. So the way I would consider synthetic biology is biological solutions outside of their native environment that have been applied with human knowledge. So what we believe is happening, or what we believe that we can do to improve those biological systems. And then thinking about natural biology. So microbes have been evolving for 3.8 billion years. They've seen some stuff. And they've built adaptation strategies around that. So there is the aspect of the natural, the observing of what those microorganisms are doing, asking the why and the how. So I think it's such a good question about synthetic versus natural, and then really taking that time to think about the human knowledge aspect that gets laid on that. Why are they doing that? How are they doing that? And what can we do to adapt them to behave in a way that we need them to do for scaling, for example, within that?
Amazing.
Yeah, so I'm going to also add a little bit to that, just so that people who don't know will get a little bit of a recap on what the different biological technologies are. So on the one level, when I talk to people who really have no idea what biotech is, I'll start talking about fermentation. So you take a couple of different things, you add yeast to them, you produce alcohol, you have beer or wine, things we all love, yogurt, cheese. That's the most basic level of biotech. The next level is engineering an organism to produce a very specific molecule. This was started in the 1970s, genetic engineering. We got insulin from E. coli, no longer had to extract it from pig pancreases, which is where diabetics were dependent on that. So you have an endless supply now. Then today we're talking about synthetic biology, which is really making biology easier to engineer. You can start pulling biological parts from different organisms, stringing them together to produce a product or to produce a certain level of metabolism. And so we can start to imagine that being applied to things like construction, Eventually, we'll be able to grow a phone, grow a house, and then from there, we'll be able to terraform planets. So that's the levels that we have when it comes to our ability to engineer with biology. Now, Ginger, one of the things we talk about is the bioeconomy. What is the bioeconomy and how would you define it and help our audience understand what that looks like?
Yeah. In my definition, bioeconomy is the utilization of biology to solve solutions that have sustainable impacts for us on this planet and jobs and the economy at large, the products that are created from that. That could mean going all the way from supply chains, like where we source the energy that's required. I think of the bioeconomy as really looking at taking an economy that's generally built upon finite resources and looking at a way to integrate more of the growth resources or the infinite resources. And that's what makes biology so beautiful, is the ability to grow and to create, but there are still inputs that need to come into that. So instead of extractive processes, being able to have more of that growth and reallocating energy resources within that.
Yeah. One of the things that we talked about, Ginger, is looking at biology. It's everything. And I like to take a quote from our friend Kristen Ellis of Lower Carbon Capital. She came on the pod and she said, the Venn diagram between biology and climate is a circle because it is the same thing. Everything is influenced by biology, even the inorganic matter. So it's huge, huge.
I do think the word bioeconomy gets used quite a bit, and especially a lot of attention in the US on building out the bioeconomy. What do we need to do to be able to achieve the bioeconomy? Certainly looking at infrastructure that we need to build. We don't have enough capacity or fermentation capacity to really achieve what some of the projections are, and some of those are conservative projections. And then also unifying around a definition. So getting more involved with, okay, well, how Canada is describing the bioeconomy, how different parts of Europe are describing the bioeconomy. So I think similar to synthetic biology, like there's a redefinition of what we mean around that.
Yeah.
Yeah, I think it's worth saying that the way the bioeconomy is described or defined in different countries is very different. So given that the United States is a very commercial, money-oriented economy, our official definition of bioeconomy starts with commerce. It says the inputs and outputs that we use to commercialize biology, something along that line. Whereas a place like Canada, they talk about the bioeconomy in its totality. So they also talk about their timber and their natural resources, which actually brings up something really interesting. I have been curious, what is the total value of all nature on the planet? The number that we hear right now, and the value has really not been defined, is something like $100 trillion, which is interesting because the total commercial economy of the planet right now is $100 trillion. But because most people don't realize that nature actually has a value, we don't value it in a way that we should.
That's right. Yeah.
We're talking about the economy. Let's talk about what's happening on the ground today. So, Ginger, how are people using biology and biotech in new ways, whether it's creating novel products or materials, and how are they getting to market? Can you tell us in the context of Biomason's commercialization story and also other things that are happening in the industry?
Yeah, absolutely. Thank you for the early introduction too about as we started off by growing bricks. It started off with a question that I had asked, hey, what if we could grow cement? Well, cement is a quite large industry. 4.2 billion tons are produced every year. It's the second most consumed substance on the planet following water. It's a huge industry, and it's responsible for 8% of CO2 emissions. So that was the initial question of, okay, something needs to change.
Yes.
We need to find a better way. So looking into biology as an answer for that. So my early inspiration was the marine environment, looking at even like all aspects of the shells, the biomineralization, our bones, our teeth, and studying what are these different processes and what's causing that reaction to happen. So getting deep into mechanisms of action, getting deep into understanding that microbes have a big part in that. They're very influential. Biomason started at TRL 0 in the second bedroom. Major mistakes to try to grow a brick. One of my early mentors was like, okay, cement is very big. Let's focus on something more tangible. Bricks are the lowest common denominator of architecture. They fit inside of your hand, and everyone understands what a brick is. We started with small petri dishes of little bricks and then grew out more full scale. That caused us to go out and decide, all right, let's start a company to grow biocement and put it out into the world. In terms of commercialization, not being afraid to say yes. So we had a client call. I mean, there were two of us, and they were like, "Hey, we'd like to place an order." You know,
Really?
and I'm like,
I didn't know.
"Let me transfer you to that
Customer service.
department." And then I changed my voice. So the question was, okay, when do you need this, and what is the volume? So it went from a large facade project in San Francisco to two fairly large courtyards. So again, two people. We got the deadline. It was 9 months, coincidentally, and we decided, all right, we're going to build a pilot plant. So we knew that we needed to do this, and it was really important. We thought of this as a licensing model very early. You can't produce cement in one location for the world. You need to be able to find a distributed model. So by saying yes to getting that early engagement, having to go through those iterations, building a foundation of multiple perspectives, multiple disciplines was really, really important. And then talking a lot with Evan at Innovator, going through a similar path. He's like, "You're going to build a plant and you know it." And I'm like, okay. So we did. We ended up building another plant to be able to address further orders and get the learnings down so that we could transfer that technology to the cement and concrete producers, that was the goal, the important aspect of it. So keeping that commercialization path in mind with how to get to that, how do you convince someone to make a change in their process? So we bought all the same equipment that they had in their facilities, and we prototyped and iterated over and over and over to be able to get it to that level.
And that took you 10 years.
Yes, 10 years. And it's colloquially known as to get a biotech solution to application, it's 10 years and 100 million. And I can attest that is true.
Amazing.
Yeah. A quick follow-up question. What type of biology were you using to optimize your microbe?
Yeah, great question. So I would say this started early on. We had an opportunity to work at Ames for the summer. So yeah, it was a question of what is the efficacy of biocement on lunar or Martian landscapes? And I love saying that with a straight face. It was so exciting.
I'm so obsessed.
Ames is NASA, for those of you who don't know.
Yes. Yeah. Walking in the hallways there and hearing about terraforming is fun. So being able to look at, okay, well, what must be true for this to happen? So we were able to look at supply chains, like, okay, where would we get enough calcium and carbon to do this? But then also the temperatures. So that was our first work into what we now know as directed evolution, for being able to push the biology through different temperatures to really prove out that case. Biology is quite adaptive. It evolves very quickly. So yeah, in a way, it was kind of like a little training for that. So that was the early days. And starting that, we had developed other technologies and other applications that required out in the wild, being able to leverage this technology to build helicopter landing pads. We can't control the weather or the temperature.
Not yet.
Not yet.
Or we kind of do, maybe? I don't know. Geoengineering? I don't know.
So being able to have a robust biology was really important, especially for not being in a position overtaken by contamination as well.
Two of the stories that stood out for me always about Biomason were, you mentioned starting in your bedroom, and on the podcast you talked about getting all this lab equipment and putting it into your bedroom.
Lab equipment from Millipore Sigma?
It was not directly from Millipore Sigma. It was from Surplus, and this was before Breaking Bad, so it was... it looked pretty
But I remember you saying that you were embarrassed to show your husband to be the bedroom because you were worried it was going to turn him off. And then the other thing I remember you saying was about the amount of sand that was in the UAE, but you couldn't use that sand to make bricks. Why was that?
Yeah. Wow. Yeah. Yeah. Dubai is the number one importer of sand in the world. It's a very fine sand. It's an alluvial sand, meaning that it's windblown and it's very, very fine. I will say that some of the early prototypes of growing bricks at that time were with UAE sand, and it's equivalent of learning how to play basketball with a tennis ball. So a lot of learnings. I was spending some time being an advisor to a council for minerals research in North Carolina. And they showed me these buckets, like 100 buckets. And they're like, check this out. And it's the overburden or the mine tailings that come from the mining industry. So like when you're blasting aggregates for making concrete and asphalt, you're not necessarily able to control the particle sizes. And it's very specific which aggregate sizes you can use for both of those industries. So that means there's 20 to 30% that is a co-product, meaning it needs a purpose. It's piling up. So we were able to take some of that back to the UAE and then bring it back to North Carolina after biocementing.
So are you saying that you could conceivably, not that you did it, but you could take those waste materials from mine tailings and also turn those into brick or cement panels?
That's right. Yeah. So the sand in the UAE is extraordinarily fine. It is an amazing resource. However, it's predominantly used as ashtrays. So when we're looking at the sand crisis that the planet is in, being able to have alternatives, so looking at the waste, and I think that's a good place to be in what I believe we're in right now in this bioeconomy and this biorevolution, leveraging that waste and finding ways of, it's a new supply chain. I think it's over 12 billion tons of mine tailings on the planet. Compare that with the 4 billion tons that are in cement. You can see these are some staggering numbers. So there's a big opportunity to be able to leverage that for other applications.
Yeah, and I think it's worth saying that there is a lot of biotech companies that are looking as waste as a resource. So this idea of creating circularity is actually really compelling right now, because if you think about, here we are in New York City, I think the number is we generate 50,000 tons of garbage per day. That's an incredible resource. For us, we think that IndieBio should partner with the Department of Sanitation to create a sanitation incubator, because that is a gold mine for the biotech industry.
Write that down.
And that is just in this city. So if you imagine all the waste that is generated around the world, Ginger's talking about the waste that is generated to produce cement. There's waste from food, there's waste in food production. All of that is potential biomass that biotech can use to create new products. Now, what are some of the pros and cons, the tailwinds or the headwinds that the bioeconomy faces right now? What are the challenges to bring biotech products to the market? Well, how do you get people interested and how do you get them to buy? And it's a very commercial question.
Yeah, it is a good question. I think that we're in a sea right now of influence of labels that come up, and it's very difficult to identify which are greenwashed. There's exciting terms that are used. I think that we're at a time, too, where there's a lot more demand for transparency. Many more mandates are ensuring that there's transparency that goes all the way to circularity and questioning. And I can say that even from aspects like architecture, architects are responsible for choosing the materials of our built environment, but we're not trained on, okay, where does that paint come from? What all goes into that paint? Even when we go to the grocery store and we go shopping, we don't know the story of where all these products are coming from. So I think that there's an opportunity to learn more about that and to be curious and question more about that. And it seems that is a trend that's coming up, but we're also combating the greenwashing that comes in hand at the same time.
Yeah, I'd made the note that we had a conversation with someone on the podcast who said that today people look at the organic label on products and what they see is premium, so they're willing to pay more. They see a bioengineered label and for them it's a warning. It's not seen as something that's premium where it should be equivalent or better. So I think that labeling is something that we should be thinking about, and it's something that requires a lot more transparency, as you say, Ginger.
And there's also a lot of mislabeling. You'll see vegan water or non-GMO water, and you're like, why? Why? Why are you doing that?
Non-GMO salt.
Yeah, it's relax. But then on the flip side, we also have seen labels that are trying to educate people more, like the Biome friendly label that we're starting to see. And whether it is or not, we'll have to see which products stand the test. But that also leads me to the next question about biomes. One of the hottest topics in healthcare amongst our friend circle, and everyone's talking about the gut microbiome. The gut microbiome is being more understood when it comes to the cause and treatment of disease. There's a documentary on Netflix called Hack Your Health, where they learned that someone who had depression and had trouble eating, they got a fecal transplant and they were able to digest their food, but then they got the depression that came along with the fecal transplant from the person. And it was wait, what's going on? How are microbes influencing us? And they are. But it's not just the microbes that are in our gut, but that are all over our body. They're in our hair and our eyes, all over different organisms and the world. And we have a great conversations with our friends, Allie and Marilise, who are here, about the Erum microbiome. And it's great to study it. So what is the research saying about the dynamics of biomes? What's happening within a biome and how do they interact? What do we know? And the hardest question is, what do we not know?
Yes, we know very, very, very little. Just looking at it from a species standpoint, we only know 1/1000th of 1% of microbes on the planet, let alone we don't understand how they're working together, the consortias, if you will. We're just now starting to understand the influence and the behavior. I mean, there's an influence on our emotions directly from our gut microbiome to our vagus nerve. I find that completely fascinating and also interesting, the cravings that we have for different foods, looking at all the different species that we have, knowing that a lot of knowledge around even the microbiome of the built environment, looking at tracking data over time, which microbial species are in decline. We spend more than 90% of our time indoors. So our microbiomes in our homes are very limited. If you have a dog, your microbiome in your home is much better. But if you have a cat, not. Maybe 2 cats is where I'm going to think.
Wait, it's better if you have a dog than if you have a cat?
For the speciation in your home.
Yeah,
your
dogs go outside.
That's right. Yeah, the cats really.
Cats don't go outside, yeah.
We put ours outside.
Yeah, Karl's cat goes outside.
On a leash.
Yeah, it's fascinating that there are conversations happening right now about the built environment and the microbiome, especially on the influence that it has on us and our health. Personally, I think that diversity is part of the solution. We need more diversity.
Not just corporates, but also in the
right.
microbiomes.
That's right.
Yeah.
Exactly. Exactly.
Yeah, I think I read or someone told us that your indoor environment has more dangerous chemicals than any other place you're exposed to. And the fact that we're in there 90% of our time is just horrifying. So what can we do to make it better?
That's right.
Besides have a dog.
Yeah, or find beneficial microorganisms to add to the built environment to really help us thrive instead of just survive. We are living indoors, and especially with different climate changes. I mean, it's pretty hot outside. So we are going to need to adapt our interior environments to be able to continue on this path of advancement and thriving.
Now, you recently started the Biome Consortia, Ginger. Could you tell us what that is and why you're motivated to start this post-Biomason?
Yeah, Biome is very new. When we were coming up with a name, we chose Biome, which we had stand for Biologically Induced Organization of Matter and Energy, to play on also biome. I mean, everything is biologically induced or influenced. And then consortia, meaning it's not just individual, it's not just one group, not one person, not one perspective, but a consortia of perspectives. So why we started this, I think a couple of reasons. A personal desire to continue to co-spire with microbes. Mm-hmm. The microbes are completely intriguing and we know so little. We have only discovered 1/1000th of 1%. I think that's a conservative estimate. I've heard that it could be nearly 35 trillion species that we don't know of. So we have all this knowledge that's around us, yet we know nothing about that. As humans, we're not able to tap into that knowledge. So how can we bring that knowledge to humanity so that we can understand better about what those influences are on us? And it's not just about us, it's about our entire planet, the ecosystems. I mean, microbes can control the weather. Talked about the influence of emotion, but they're a key part. They're this invisible frontier that we know so little about. But yet imagine how many solutions are out there to some of the major problems that we have, especially in climate change. So we started it very early and we've been growing it and had a lot of great conversations and some exciting things going on at Biome right now.
That's awesome. So you're talking about a consortia, so different types of stakeholders coming in. What kind of activities do you imagine these stakeholders doing when they come to the consortia? Can you walk us through an example? Like how could they leverage working together?
Yeah, so for us, what's important is, okay, how can we learn as much knowledge as we can from the microverse, and looking at this goal? It's a very lofty goal, big goal of how can we have an interconnected library or database that's open access, that has knowledge of the microverse with solutions. Like, how can we have a searchable database? We've seen that there's been efforts to have strain banks or biobanks, or even efforts like the Encyclopedia of Life or the Microbiome project, all amazing endeavors. So what can we learn from those efforts that are happening right now? How can we combine our efforts together so that we can work towards that shared vision and that shared goal within that? So I would say where we've been in the past few months has been on almost like a big listening tour, getting a lot of different perspectives, being very curious about, okay, what would it take and what should the goals actually be? How many do we know? Is that information searchable? Have we standardized how we're looking at the data? No. So finding the bottlenecks, if you will, like, okay, if we want to be able to have this globally accessible database, being able to leverage standardization within that, and then getting additional stakeholders involved that include all of us, and looking at, well, what problems do you have? What solutions are out there? We don't have a way to search for that right now. And I can say, just from the example of Biomason, like, okay, hey, how do we grow cement? Well, it came in a roundabout way, like, oh, wow, there are microbes that are out there that participate in all types of biological cements. They're found in soils, they're found in the marine environment, they're found in caves. So that becomes a target, where to go. So how do we start prioritizing where are our biggest challenges right now? Starting at Biomason, it was cement. Cement's a huge industry. There are many other big industries out there that need a biological solution for that. And it's not just going after the big commodity type of based solutions. There are all types of solutions within healthcare, or even just a way to allow humanity to thrive instead of just survive. So, what if we could breathe air that's the forest? We've talked about forest bathing quite a bit. You feel better being out in nature. What does that mean? It's scientifically, this visual aspect or the light changes, there's a physiological response that our microbiome is having with a forest microbiome. And that's just one example. Looking at penicillin, that makes a lot of sense for, like, okay, we have a problem. It is a pretty urgent problem. So having to go and source mold from a cantaloupe, for example, which in the case of penicillin.
And you kind of described what the ultimate goal is, but what is the ultimate goal of the Biome Consortia?
Yeah. So an interconnected library that's searchable. It's a growing library. I mean, biology is evolving all the time. The microverse is immense. We can't even imagine how big it is. I mean, all of our microbiomes right now are evolving and adapting and exchanging information. We don't know what that means. We don't know what it means for different organisms or species of organisms to work together. It's that interconnectivity. We've been very focused and very good at looking at singular microorganisms and trying to understand how they behave. But what do they behave like in a consortia? What does that mean? This is a massive effort. It's a lot of data and a lot of information. However, we're at a time right now where there are a lot of advances in modern AI. So being able to leverage AI to decomplex all this. And what that means is we need to go and bioprospect and sample with gathering additional data rather than just the organisms themselves. But that environment, that environmental data, those consortia that are around them.
Yeah. You're saying standardization of data, and I hear all the tech bio people be like, yes, standardization of data is what we need. So I think that's going to be an amazing effort, and it has to get started from scratch. So it's amazing.
Yeah, it's a lot of fun to work on this, and it's been a lot of fun working with you guys on this. And the other aspect too is aligning around what does it mean to deploy nexus of research. So for example, institutes. We looked at how in the US we have national labs. Okay, these focus areas for being able to dive deeper into these subjects. This is a lot of information to start to dig through. But if we really want to make this bioeconomy happen, which I believe we do and we can, that is one of the bottlenecks, is having access to that information.
Yeah.
Yeah.
I think one of the things that we've tried to emphasize this year on the podcast is the globality of the biotech industry. And one of the things that I find super interesting about what you're doing, and also seeing biotech become more democratized, is solutions that are developed on a very local level. Mm-hmm. So for example, our oldest son, he did an internship in Maine at MRI, which is an institute there, and they were incubating biotech companies that would have existed nowhere else. There's biotech companies that could be developed here in New York City that would exist nowhere else, and then nor should they. And people could end up building these really nice businesses based on locality. And I think having access to something like the Biome Consortia and what your ultimate goal is, I think is going to help catalyze more of that.
Hi, a quick shout out to our sponsor, Messaging Lab, the force multiplier for biotech. Your biotech company is making the world a better place. You know that, we know that. But does the world? There's a big reason why some biotech companies attract investors, sign up customers, and get attention. That reason is strategic communications. At Messaging Lab, we translate complex science and economics into compelling narratives. And we have done that for the most successful biotech companies across healthcare, agriculture, personal care and beauty, materials, and the list goes on. We're here to make sure your ideas not only get heard, but resonate with your audience. So if it's time to amplify your company's voice, visit messaginglab.com to explore how we can elevate your story and grow your business.
I am a huge fan of distributed applications and solutions. I think we're past the place where we have a silver bullet for every problem.
Yeah.
Awesome. Well, I think at this point, we can start opening it up for Q&A from the audience. So we would love to get those mics out and hear from you guys. Any burning questions? I see a young gentleman, back there. This must be a young college student that we don't know.
That's me.
We don't know him at all.
So imagine 75 years into the future, microbes have somehow helped us save humanity. What does culture and technology look like in that future?
God, start us off with an easy question, Dan Grushkin.
Thanks. Wow.
I hope it's beautiful. We can't imagine what we can't imagine. Having intentionality, partnering with microorganisms could be quite interesting to see what we could make together. Maybe less rectilinear shapes.
Yeah.
Maybe that.
Oh, yeah. Yeah.
Maybe some underground habitation, a bit more.
Hopefully some off planet. Dan, one thing I would say to that question, I think it's super interesting because we need more people imagining what those futures look like. I mean, if you look at science fiction, the internet was not really something that was necessarily in science fiction. Same with the iPhone. These things suddenly appeared, but people had to be thinking about them. And so I think it's hard for us to imagine what 75 years looks like, but we really need to because of the pace of acceleration that we're living through right now. So I think it's a profound question, and I think all of us in this room should be working on thinking about what do we want it to look like, especially when we consider the evolution of these technologies.
Yeah. I would just add to one thing is that I really hope that more people are educated about biology and microbiology, and it influences their decisions from the day to day. So littering will never happen. We recycle. It just becomes a more healthier place. And then, yes, off planet.
We've got a question up here.
Thank you. So first of all, I'd like to say it's just incredible. Just coming up with the idea, wow, it's incredible what you've achieved. So my question is, there must be some cons, meaning what are the challenges if you had to compare it with the traditional bricks, concrete? How predictable is it? How reliable is it? And second aspect is if you had the price to manufacture one and the other, what are the advantages of what you've achieved compared to the traditional manufacturing process? Thank you.
Yeah, thank you. Yeah, great question. I think that's part and parcel for choosing a hard to abate industry is looking at cost in the face, really getting creative about supply chains. I think maybe one way to answer this is, and it affects the bioeconomy as well. We're not going to build our future on corn and stainless steel. We have to find less energy intensive and less expensive means for growing the bioeconomy. And that means going to waste resources, leveraging the waste. We learned that early on, more from the waste mine tailings, if you will, but finding unique opportunities to, again, not just try to imagine, okay, this one solution blanket across the planet. Humans are very good at wanting to put those types of solutions like, okay, here's this one formulation for cement, for example. Well, now we see what happens when we do that. So being able to have more diverse supply chains going into the inputs, because you have to feed biology an energy source to be able to do that at ambient temperatures. Consistency, yeah. Again, a really good challenge. When I was in graduate school, we had an opportunity to do a project called Death by Units. And then I guess I wasn't done because it continued. So making sure that there is that consistency, because in concrete, it's not like you can go crush a skyscraper as it's going under construction and be like, that's the compressive value. You have to be able to find different ways of testing. So typically what happens is you do spot testing for different aspects. We were interested in, okay, well, how can we sense the process as it was ongoing? You can't see the microbes doing the work. You have other ways of sensing what's happening. And to be honest, smell is a big one, being able to understand the different biomolecular exchanges that are happening. So consistency, very challenging, but at the same time necessary, or it's not worth it. You can't have one that's this big and here's one that's this big and inconsistent. We have to have reliability. It's one of our basic needs for shelter.
You guys were extremely rigorous in growing brick in terms of measuring their performance characteristics. When you create things with biology, you end up with different performance characteristics than you would if you make them the way we're used to making them, which is one of the things that makes it very exciting. So for example, I think your bricks, and I know the Prometheus product, Prometheus is another biomineralization concrete company, they have found that their concrete has thermal and acoustic properties that concrete does not have. But you guys went through that as well.
We did. From day one, it was more about the data than the object. So needing to know its performance. That was a lot of our background that we brought in was material testing and material science. It was something that we had both done in graduate school and then built this team of 56 different disciplines to be able to look at that. There's a famous quote from the architect Lou Kahn when he asked a brick, what do you want to be? And the brick said an arch. There was a question, an arch. Yeah. We were observant, like, oh, okay, well, what are some fascinating aspects of the performance and properties? And for us, in the years that we were building out pilot production prior to Series B, we were investigating freeze thaw. Why our freeze thaw was performing much better than Portland-based cements. And it was a curiosity of like, why? So really starting to dig into and looking at how the crystallization is happening around the aggregates as opposed to Portland cement, which is more of a gel, if you will, of different crystals that grow. So engineered crystals that are directed and grow where you need them to grow. It was fascinating, especially getting into microscopy on that. So yeah, and then learning too, we were able to do a project with DARPA, I think at the same time we met, is when we started to meet up with DARPA and about engineered living marine cement. DARPA came up to us and said, well, hey, we think it's really interesting what you're doing, but what else can it do? How can it live in perpetuity? It's like, challenge accepted. So being able to investigate what that meant for, let's say, living seawalls in the marine environment, they're able to grow and continue to harden, not ice 9, the planet, but being able to harden in place. And concrete underwater is a big problem. It typically lasts between 15 to 20 years, and then you have to go repair it. So imagine having a cement and concrete that continues to get stronger. And if something hits it, the crack self-heals and grows, and you're able to not harm the surrounding environment and the ecosystem. So yeah, weird things to learn along the way, the power of biology. That's just a tiny scratch. The surface, we know nothing even about some of these materials. And Portland cement's been around for 200 years. And we still don't know exactly how Portland cement really works. So,
Do we have time for
One more.
Cass Smith?
These are the hard questions.
Is it a plan?
Hey, thanks, Ginger, for coming tonight. My question is about Biome Consortia. I'm just curious about what types of individuals or teams do you imagine being the collaborators or partners? And then I'm also curious about the incentive structure to add their data to the mix. So, thanks.
Yeah, really great questions. We are building the ship as we're flying right now, which personally I think is really important. It's being able to take the action now as opposed to waiting. So we are very new in this. And part of our listening tour and gathering these different perspectives is looking at those larger efforts that have happened and learning from them on what's worked, what hasn't worked, where things get caught up. What does it mean to have a singular funder, for example? What does that mean if there are issues at governance? That can be a big problem. So then looking at, well, how do we open up different libraries via pledges and looking at opening up that access? So we are going to have a workshop coming up. Maybe we can talk more about that and get some of your perspective on that too, because there's quite a bit of risk analysis too, especially on shaping this out. So being able to get those multiple perspectives and moving forward on that. It is rather building out a movement under the shared belief that we should have access to the microverse and the microbiological data and being able to leverage that for solutions that we can match with the problems that we have.
And then one thing I want to talk about is possibly doing a citizen science part of this. Because there's trillions of microbes, there's only billions of people. So
that's right.
Everyone can
We need 8
participate.
billion people to help with this, send a spoonful.
This means that there's at least a few microbes per person on the planet.
Yeah.
More than a few.
I mean, it's fascinating too, like looking at the pipeline or the plume. We don't have the capacity to be able to characterize all of that. And in my opinion, and maybe it's because I started off as a citizen scientist. I'm not going to call myself a scientist. I definitely, worked with microbes.
Check up all the boxes.
Oh. It's definitely about curiosity and driving that curiosity. I mean, I don't know. When I first learned about microbes, I was blown away. I learned about the microbes that live on our eyelashes. It was a very gross story, so I'll spare you that. I mean, it was just a fascinating story. So having more of that curiosity of citizen scientists and what we can do. I think what's missing in some cases, and we talked a little bit about this in the podcast today, is imagining what you can do. What are the applications that are possible? So as we're building this out and building out the workshops and the shaping strategies of trying to build out a chart of what are all the different possible sectors, and then getting ideas about what could be possible. It takes all of us. It's not just about singular disciplines. I think it's going to take all of our disciplines and all of our imaginations together.
Do we have time for one more?
There's a gentleman over there.
Can you speak more about the commercial viability, or what are the future plans for Biomason?
Yeah, so Biomason is thriving right now. The important aspect with where Biomason has gotten to is the international commercializations. I'm sure that there are many updates that continue to come out of that, but the focus on the precast concrete construction market, especially in areas like Northern Europe, which precast concrete is more prevalent than ready-mix concrete, if you will. What was so fascinating about working with those partners is that they have over hundreds of SKUs, and that's not something that we wanted to do. So being able to have those early partnerships, and the model is to continue to find additional partnerships.
Excellent. Well, thank you so much, Ginger. This has been an incredible privilege. Thank you for giving us so much to think about.
Thank you so much for coming, and happy networking, and enjoy the rest of the evening.
Thank you.
So, Karl, what'd you think of that live recording?
It was so much fun. We had such a good time. I think it sounded great. Ginger is so good. I love having the conversation with her. We've had her on the podcast before. It was great to have her be live with us. What did you think?
Yes, I agree. It was a lot of fun. Of course, when we do anything live, whether it's this live recording or speaking on stage, we do get, I know you do, I do, we get a little nervous. Like, okay, are we going to say everything? I know you recently posted on LinkedIn about performance anxiety, and you mean about presenting in front of people.
Yeah, I tried to come up with the most clickbaity headline to pull people into the article. So I admitted I have performance anxiety.
Yeah, that's the game we have to play.
Yeah, but we got some great feedback. People really enjoyed it. I think it's worth, again, thanking the organizers at Biotech XYZ, IndieBio, Millipore Sigma, and our friends at NYU Langone Biolabs. They all made it possible. What do you think? Should we do it again?
Yes. Yeah, absolutely. Absolutely. I think to interact with the audience and have them ask questions, we're talking about very deep subject matter. Some of it's tangential. So a lot of people in the audience were familiar with biopharma, but maybe new to bioindustrials. So they're trying to make the connections. Anytime I hear big ideas, I automatically feel like I want to ask questions because a lot of people that are interested in science are curious people. So I think that's a beautiful thing to be able to have those questions. They were really good ones. And I loved Cass's question. I loved Dan Grushkin's question. We had some other people ask great questions. And of course, we would never think of. I mean, they have their own personal experiences. They want to make sense of what we're talking about on stage, what Ginger did a wonderful job of talking about. I mean, it's always great to speak with her on the record and off the record. We always learn something new. And yeah, I mean, maybe do a live recording with different crowds. This was Biotech XYZ, but maybe like, I don't know, a developer conference or something that's so out there that it's like, yes, we need to bring more programmers into biology. We need to bring more artists. Maybe we go to like, I don't know, South by Southwest.
Yeah. Yeah. I mean, you bring up an interesting point. You said something like everyone's curious. And I'm like, yeah, everyone's curious because at our hearts, we were all curious people and we were all scientists. So really appreciated all the questions and appreciate the questions that people ask us in general. But I think we should try to do it. I think a developer conference is actually really interesting. I've already been approached by a couple of people. So perhaps we will be doing this sooner than we think.
We could do like a tour. A road show. All right. I'm booking the bus. We're going to go to a 6-city tour of US. And then next year we can do something international.
There you go.
All right. It's on the books, guys.
All right. So coming up, what do we have in front of us? We've got a couple of episodes we've already dropped. There's a bunch of really good ones that we haven't recorded but are coming up as well.
Yeah, absolutely. We have an episode with Dennis Kent of Prolific Machines. That was such an interesting conversation. It's going to be great. Listeners, please stay tuned for that. We're going to be interviewing astronauts, head of sciences and healthcare at NVIDIA, authors, other scientists, investors. It's going to be a great rest of the year. I can't believe it's August already. Wow, time is just zipping by, but here we go. We are bringing more biology straight to you, straight to your eardrums. And we're really excited. So please stay tuned to the Grow Everything podcast, where you're learning about how biology is transforming the world.
And feel free to send us any questions. We do have a hotline. You can become a Patreon member to become part of the community. The money goes directly to our producers. We don't make any money from this podcast, but we do appreciate everyone who is a Patreon member. And thank you so much for listening.